Friends, welcome to Unacademy. How are you? So I hope you are perfectly fine and your preparation is going absolutely fine. So in today's video, we are going to talk about one more very interesting property of fluid, that is surface tension. And what I see that most of the time students are always confused about this surface tension, and whatever concepts you have, that may be not sufficient to answer the questions in interview. Okay, that may be sufficient for answering the GATE problem or maybe ESE problem. That is fine, but it may not be sufficient to answer the question asked by the interviewer. So let's start the session. Okay, so if everything is fine, if everything is fine, audio, video, everything, then please just say thumbs up and just like the video. As I told you earlier also, that whenever you are coming to my sessions, you have to wish and then you have to like the session, and then only we'll proceed for further. Okay, so before going further, let me introduce myself. Maybe many of you are not aware about me, or maybe you are new in this channel or in this video series. Then I would like to suggest you about that if you are new here, then whatever lecture already covered, right, approximately 6 lectures are already covered. So those 6 lectures you have to cover by your own, right? First go and cover those lectures. Okay, so let me introduce myself. I'm Shivam Dixit. I did my MTech from NIT Calicut in thermal science, and after that I got selected for many PSUs including IOCL. And from last 9 years approximately, I'm in this teaching, and I'm guiding the students for GATE and ESE. And from last 9 years, I have guided more than 50,000 students, and many of my students secure single digit and double digit rank. So as you know that this series is basically that it is a short term course or crash course for those students who want to get some good rank in upcoming GATE exam. But many may have a confusion, sir, is it like possible for to get a top notch rank in this 4 to 5 months of preparation? I would say definitely it is possible. I can give you the examples. Tomorrow one video is coming, one topper video is coming in our platform itself. One video is coming because many students are asking about this. Sir, 5 months is enough or not? I just started preparation. My preparation is only average. So will I get the good rank or not? All these answers will be given by one topper in 2018. In 2018, one topper was there and he secured AIR 53. So yesterday only I asked him to prepare one testimonial video so that student can get motivated. So he had made one video, and that video I have shared to the team. Hopefully they will upload it very soon, so you can watch that video. In that video he clearly said that he completed his BTech right in 2017. After that he joined one automobile company, and then at the month of November, not even October, in the month of November he left the job and start preparing for this GATE. And when he start preparing for GATE, before that around 7 to 8 months he did not study anything, any subject. So from November months onwards he started preparation. He taken guidance with me also, and then he secured AIR 53. So I hope that this story will definitely motivate you, and that video is coming tomorrow. So you just watch that video, and you will get one confidence that no, the people can do in 4 to 5 months, and that is more than enough. What do you think that whatever you studied last year, will you able to remember it? No, obviously you all the things we forget. So whatever you are going to study in last 4 to 5 months, that is only going to be remain in your mind, and that is only going to play the crucial role in your rank basically, right? So this is all about this one. So whoever is start preparing and whoever is preparing through these lecture series, I'm damn sure that you can get a very good rank. Please continue your preparation up to the last day, up to the last moment. up to the last moment. Sometimes people are say that don't study 10 days before the exam. झूठ बोलते हैं. No, you have to study up to the last moment. Up to the last moment you study. Correct? You just keep on revising your formula up to the last. I personally feel that that is the only thing, right? If you leave your study 3, 4, 5 days before, you will forget everything and you will get demotivated. Other people are studying, I am not studying. So it will demotivate you. So up to last moment of the GATE exam, you have to give your 100%. I'm damn sure you are going to get very good. Even 2018, the number of students was more than 2 lakhs. Now currently only 70-80,000 students are appearing in GATE exams. So even competition is decreased like anything. Competition nowadays, competition is decreased like anything. You can easily get the top notch ranks, right? So this is the thing. And one more thing before starting this lecture, because I told you today we are going to talk about somewhat vapor pressure, some introduction I given to you earlier, and even I gave you one question also. I don't know whether you got answer or not, but what most of the people don't get answer, I'm damn sure, right? Because as I asked you that this earthen pot is basically violating the second law of thermodynamics. It seems like that, but actually it is not. So we'll see basically. Now the second very important point that I am going to discuss, surface tension. This is most important property, and most of the time when people are asking questions on surface tension, right, in interview, then most of the students are not able to answer. So interview point of view, surface tension is one of the most important property of the fluid. Okay, for GATE point of view also it is fine. There is somewhat importance is there. So that's why today we will try to complete this particular chapter, and tomorrow we will start the pressure and pressure manometer on Pascal's law, hydrostatic law. So manometer will complete, U2 manometer, right? And then after that we'll go for single column manometers, differential manometers, barometers, correct now? So all those things we are going to discuss in tomorrow's class. So these lecture series will cover all the concepts of fluid mechanics that may come in upcoming GATE exam. So if you are following me seriously and honestly, very important, seriously and honestly. Sir, what do you mean by honestly? Honestly means sometime you are coming here, sometime you're not coming, sometime you are watching, this, recorded version, right? No, this slot will be fixed, and you are not even giving respect to your faculties, you are not giving respect to your parents, then you are thinking that you will be successful in your life. Not possible at all, right? So this is all about me. Okay, now before starting, one more thing, just like the session and share this session in your groups and write that class is live. This you have to do every single day. Okay, now before starting, one very important point I would like to share here, that from today onwards, one big offer is there from Unacademy side, right? From Unacademy side, one very big offer is there for all the students, that they can get 20% of off, right? Up to start date was only 10%, but that will be only if you are using this code SHIVAM Shivam 101. If you use this particular code, then you will get 20% off in all the subscriptions, right? So you can see that even if you are taking for 12 months, I'm taking example, then this is, then how much you are going to pay. Basically you are going to pay 34,000 and you will save 8,000 rupees, right? And in 6 months, basically if you are going for, then 27,000 you have to pay, you are saving 6,000. So this is basically all these things. Okay, fine. So I hope you understand this. Let's move on. But okay, one thing is you need to understand that this code only you have to, whether you take or not doesn't matter, but if you are taking in future also, or your family member, someone is taking Unacademy or friend or whoever, you have to say that this is the basically thing. Okay, done. Hi, Mr. Boss is saying hi. Felix Wankel, just like the session beta, and let's start. Okay, okay, very good. Thermal Baba, Nikhil Gaikwad, I know you. You are from Maharashtra. I know you are from Maharashtra. I have met you number of times. दीपक सर फ्लूइड मैकेनिक्स कंप्लीट हो जाएगा ना? अरे 100% कंप्लीट हो जाएगा, डोंट वरी दीपक कुमार, डोंट वरी। अरे फ्लूइड मैकेनिक्स भी कंप्लीट होगा, थर्मल भी कंप्लीट होगा, डोंट वरी। Right, so most of my favorite students are here, so let me start the session. But you people are not sharing this to your groups. Just go and write in your sessions, just go and write in your groups that class is live, class is live. Just go and write. Okay, let's start. So yesterday I ask you that how this earthen pot is basically working. Now first I am going to explain that how this earthen pot is basically working. You just assume that I have one earthen pot. This is earthen pot. Please listen here carefully. Please listen here carefully. This is earthen pot, right? Or matka. This is also called as what? Matka or kunda. In Telugu it is called as what? Kunda. In Malayalam what is the name? Anyone? In Malayalam, what is this name? And in Tamil, what is the name? In Kannada, what is the name? You just tell me the name of this thing. You just tell me what is the name in all the language. Hindi, I told. Hindi, it is matka. English, earthen pot. Telugu, it is, I told you that is a kunda. Are you from AP? I am half AP. Actually, I am from UP, right? I born and brought up at UP, but my studies and my career, most of the part of my career is in AP, and most of my studies are from Kerala. Okay, in Tamil it is a Pannai, so we have one Pannai. Okay, we have one Pannai. Okay, fine. Now please listen here carefully. This is very, very, very important. This particular thing is very, very important. Now please listen here. Actually here temperature role is not that much important. The role here, heat transfer role is not that much important. What is important? Mass transfer is important. There is two mode of energy transfer. See, what is your subject, right? That is most of, see, our syllabus, our GATE syllabus, only heat transfer is there as syllabus. But subject name is heat and mass transfer, HMT, heat and mass transfer, right? Why? Because we can transfer the energy through the mass also. That you will understand. Wait, so here I am filling the water. I am filling here water, that is, let's say, at 30 degrees centigrade. That is at 30 degrees centigrade. Here also 30 degrees centigrade only. This is also 30 degrees centigrade. Now see, if you want to convert liquid into vapor, if you want to convert water into steam, then two methods are there. How many methods are there, beta? Two methods are there. Let's say you just start heating the water. See, what is the boiling point of water at atmospheric pressure? What is the boiling point? Boiling point is 100 degrees centigrade. See here, if it is a 1 atmospheric pressure, it is a 1 atmospheric pressure, then boiling point is basically 100 degrees centigrade. Boiling point is 100 degrees centigrade, correct now? Now let's say if actual temperature, let's say 30 degrees centigrade. Please listen here. We have water at 30 degrees centigrade and pressure is 1 atmospheric pressure, right? Now I want to convert water into steam. Then one method is you just start heating it. What normally you are doing the same thing, no? You just start heating. When you start heating, beta, then what will happen? The temperature will start increasing. 30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree, 100 degree. When it will reach the 100 degree, then it will start vaporizing. This process is called as vaporization. So in this process, what exactly you did? You increases the temperature, basically. You increases the temperature. Now another method also I have one more method to convert liquid into vapor. Do one thing, you start decreasing the pressure. When you decrease the pressure, then boiling point will decrease. This is the boiling point at 1 atmospheric pressure. See, you may heard that it is difficult to cook the food in mountains. It is difficult to cook the food in mountains. Why? Because in mountains the pressure is very, very less, right? Atmospheric but local pressure is very less. Now if pressure will be very then boiling point will be low. Boiling point will be low. Boiling point will be low means what? Water will start boil at 50-60 degree temperature only. If water will start boil 50-60 degree temperature, then how this rice will cook? Suppose आपने क्या किया, एक you have taken one pot, right? एक pot लिया, उसमें कुछ rice डाला और दाल डाला, right? Now you are start heating it, then it will go up to 60 degree. In mountains 60 degree. Now at 60 degree it will start boiling. So after that temperature will not increase, or it is very difficult. It's quite impossible, quite very difficult, and not impossible, but it's very difficult to cook the dal at 60 degree temperature. At 60 degree temperature, pressure cooker is must. Pressure cooker is must. Okay. Now come to the another point. So what I'm trying to say, if pressure will increase, boiling point will also increase, or another word, if pressure will decrease, boiling point is also decrease. So what now I am going to do, I am going to decrease the pressure. When I start decreasing the pressure, then after certain value, the boiling point will be less than 30 and water will boil. This process called as evaporation. This process called as what? Evaporation, basically. Now, so evaporation is basically due to the pressure, right? Partial pressure, basically, that you will understand. Just wait. And vaporization is basically temperature. So when we are increasing the temperature, it reaches to the 100 degree and vaporize, right? If we are decreasing the partial pressure or something, then what will happen? It will convert into vapor. That is basically evaporation. Now I hope you understand. Now please listen. Thermal engineering, when you will teach, अरे पहले जो पढ़ा रहा पहले वो पढ़ लो यार, जो पढ़ा रहा वो पढ़ते नहीं तुम लोग, केवल हमारा टाइम पास कर रहा है. Okay, now listen here. Now listen here, everyone. Now what is going to happen, sir? Here what is going to happen? Now you know that this earthen pot is made of. Someone is calling me. ओम प्रसूति, अरे भैया कल कॉल करना यार भाई. Don't call now, right? Don't call now. Now please listen here carefully. So here inside what we have water, and this earthen pot is made of porous material. So due to capillary effect, due to which effect? Capillary effect, that we'll understand later. So capillary effect, this water point molecule will reach here. Water molecule will reach. Now this water molecule wants to go out. Why? Because here unsaturated air is there. Now this is most important part. Unsaturated air. See, whatever air is there, that air is unsaturated. What do you mean by unsaturated? See, in air two components are there. One is dry air. Dry air means O2, N2, helium, all these particles. Another component is wet component, that is water vapor. Two things are there, right? Now if you start adding vapor to the air, then what will happen? After certain condition, it will be saturated condition. After that, you will not able to add vapor. Many people are confused. Please listen here carefully. This concept is not that much easy. Suppose you have one glass of water. The water is basically unsaturated, corresponding to sugar. Now you are adding sugar at particular temperature. Adding sugar. After some time, what will happen? After some time, it will come to the saturation condition, means you will not able to add sugar further. But this saturation state is corresponding to one temperature. If you again heat that water, now again you can add sugar. You are getting my point or not? Now same thing is happening in air also. In air, at a particular temperature, you are adding vapor, adding steam, steam. After some time, it will come to the saturation state. After that, you will not able to add steam further at that particular temperature. Either if you want to add more, then you have to increase the temperature. Now please, so here unsaturated air. Unsaturated means we can add water vapor. So this wants to transfer, this wants to go. Why this was? Because of concentration difference. Because of what? Concentration difference. Many people don't understand it. Again, listen. Suppose you have one glass of water. You have one glass of water. In that glass of water, do one thing. One experiment I'm telling you. You just put some sugar here. You just put some sugar here, or salt or sugar. You just put. Slowly what will happen? You don't mix it. Don't do anything. Slowly what will happen? It will automatically start mixing. Slowly it will automatically start mixing. This process called as what? Mass transfer. For mass transfer, what is required? Concentration difference. Here sugar concentration is more, here sugar concentration is less. That's why it will automatically transfer. Now listen here. Here water concentration is more. Here water concentration is more, here water concentration is less. That's why it will automatically transfer, right? It will automatically transfer, right? This molecule, now this molecule wants to go out, but to go out it have to change its phase, na? To go out it have to change its phase. To change its phase, what is required? It required some energy. Are bhaiya, liquid phase hai na? This is in liquid phase. So if it want to go out, then it have to convert into vapor phase. To convert into vapor phase, some latent heat is required, na? So what it will do? It will take the energy from this molecule. अरे समझ में आ रहा है कि नहीं? Earthen pot evaporate. For the evaporation, it takes a heat on the pot itself and water inside. Okay. Thermal engineering. Good evening, sir. I am returned home from hostel, so I am attending today's lecture now. I look at. Okay, fine. Okay, please listen here carefully. Please. मैं क्या बोलता हूँ ना? Suppose you are there, right? Suppose you are there. Suppose this is you, right? Suppose this is you. This molecule. Suppose this is you. Your name is, let's say, Champak. Your name is Champak. Now this Champak wants to go out. This Champak wants to go, let's say, Bangkok. This Champak wants to go Bangkok. Now why he wants to go? Because of concentration difference, right? Because of concentration difference, he wants to go Bangkok. Bangkok means this is a Bangkok, unsaturated air. This is a Bangkok, and he wants to go, this is a molecule, and he wants to go Bangkok. But for going Bangkok, how much amount of rupees is required? 3 lakh rupees. If you are spending good amount, right? Even if you have less money, then in 1.5 lakh also you can manage. I have personal experience, right? So this Champak wants to go to the Bangkok, right? But he have only 1 lakh rupees. He have only 1 lakh rupees. So what he will do? He will take money from this Champak. He will take money from this Champak, and this Champak will go out. Now process is done. Now after that, what will happen? What he will do? Why he is giving money? Why this Champak wants to give the money? Why he will give the money? Because at every evening he will call to this Champak. This is Champak 1, this is Champak 2. Champak 2. Now Champak 2 will call at every evening. क्या चल रहा है उधर? What is going on? Everything is fine. कोई पुलिस का लफड़ा तो नहीं है? No. So Champak 1 said, no problem at all. Here everything is perfectly fine. So what he will do? Now he will take again some money from the Champak 3. And he will also go to the Bangkok. What is basically happening? This molecule is going out. This wants to go out because of concentration difference, because here unsaturated air is there, and this it will take energy from their own molecules. It will take energy from there. So this will also take this. So basically what is happening? Happening is like whatever molecules of water is there, these molecules are leaving the system, leaving the earthen pot, and taking the energy from their own molecules. That they are not necessary to be complete energy is taken from own molecule. It will take some part from this air, some part whatever outside air is there, and some part it will take from their own molecules also. Now please listen here carefully. Please listen here carefully. So slowly you can see that molecules are going out, and the energy level inside the earthen pot is decreasing. Mass is also decreasing, energy is also decreasing. That's why temperature will also decrease, right? Temperature is also decreased. Now, so this is the basically phenomenon. Now, up to when this will continue? Up to what condition it will continue? It will continue until unless this air will be saturated. This air will be saturated. You are getting my point? Once it will be saturated, then it will not go. Then it will not able to go because flight is full na. You must assume that air is basically flight. So if air is unsaturated, means in flight space is there, seats are vacant. But once air will be saturated, means all the seats are full, no further molecule can be added. You are getting my point or not? So and that is depend upon the temperature. So when this temperature will decrease, so at certain temperature, right, the air will be saturated corresponding to that particular temperature. Then what will happen? Then this process will stop. Now and that pressure is actually called as saturated vapor pressure. That pressure is called as what? Saturated vapor pressure at that particular temperature. Now it means that when these molecules are going to be evaporated, these molecules will only evaporate if air will be unsaturated. See, this earthen pot is working perfectly in May and June. But once July is coming or August is coming, in that particular time rainy season is coming. In rainy season it will not work properly. Why it will not work properly? Because the air is saturated. When air is saturated, then what will happen? Then the evaporation will not take place. What is the main criteria for evaporation? Is it temperature? For vaporization, temperature is responsible. But for evaporation, what is important? The air must be unsaturated. Saturated means, please listen here. Suppose total pressure of the air is 101. Please listen here. Total pressure of air is 101. Out of this, the pressure of dry air is approximately 99, for example, 99, and this is 2. If air is unsaturated and this pressure is 2, now if you add water vapor, then what will happen? Then this partial pressure will increase and it will the value will be maximum when it will become saturated. Is this point is clear? Now your water cooler is there. Water cooler is working perfectly in May and June, but it will not work properly in July, August, September, in rainy season. Rainy season, you can see that direct droplets are coming in your body. If someone is from North India, they can understand this point. If someone is from North India, they can easily understand that if you are from Delhi, UP, Bihar, Rajasthan, right? So you may see that during May, June, right, your water cooler is working perfectly. Very cold air is there. Wow, AC jaisa kaam kar raha. But once rainy season will come na, right, once air will be saturated, then what? Direct water droplets are coming to our bodies basically, right? It will not vaporize, it will not evaporate. Water droplets will not evaporate, because to evaporate it must be unsaturated. Unsaturated means partial pressure of vapor is PV. Saturated water, even it will saturate, then it will denote a PVS, and PVS is greater than PV. सर एरोस्पेस इंजीनियरिंग गेट कोचिंग के लिए कहाँ जा सकते हैं? I don't know beta, really do not have idea. Sorry. Please listen here carefully. This concept, please listen carefully about this concept. This is not an easy thing. Even there is one topic in thermodynamics, that is psychrometry. So in psychrometry, I'll teach that topic approximately 8 to 10 hours. That topic I will teach in 8 to 10 hours. And after teaching all those concepts, then you will understand that how the water is being cooled in earthen pot. See, see here, lot of concepts are there, but I cannot teach all these concepts here because it will be waste for FM. See, temperature is decreasing. So And in case of earthen pot, temperature will go up to certain limit, let's say 22 temperature, 20 temperature. After that it will not decrease. It will, see, you can see that whenever earthen pot is there, if you put some water inside, then what will happen after 5-6 hours, water will become cold and come to the 20 degree. But if you leave it for 10 days, it does not mean it will become ice. It will not become ice. Why? Because that have certain regions. You are getting my point or not? So same concept is there to dry the cloth. To dry the cloth also similar concepts are there. Now please listen here carefully. But now I'm going to summarize the thing, because this is very wide topic, and if I start explaining, then 2-3 hours will be required, right? So now what I'm going to say, very simple thing. In earthen pot, very simple thing is there. If the pressure will be less than saturated pressure, if pressure will be less than saturated pressure, then evaporation take place, then only evaporation take place. If somewhere pressure will be less than saturation pressure, then only evaporation take place, and evaporation always leave cooling effect behind it. This evaporation always leave cooling effect behind it. Only this much you need to understand. Rest concept I will teach you in psychrometry. That's it. Now come to this particular point. So what I'm going to tell you, that in case of water, let's say here we have water, right? So here we have water. So what is the tendency? Here we have unsaturated air. What we have? Unsaturated air. If unsaturated air is there, then what will happen? These molecules keep on adding, right? Because air is unsaturated. So this process is called as evaporation. This process is called as what? Evaporation. So if evaporation will take place, then these molecules will add continuously to the unsaturated air. Why? Because it is a mass transfer, because of concentration difference, okay. Now what I'm going to do is, now I'm going to close this with a lid. I'm going to close this, right? I'm going to close this. So what will happen? It will keep on adding. After some time, the air inside the glass, here air will become saturated. Here air will become saturated air. When it will become saturated air, beta, then the pressure will be PVS. So at this time, whatever partial pressure of saturated air is there, that is basically called as vapor pressure. Either you say vapor pressure or saturated vapor pressure. Please, again I am telling you this concept. See, if suppose you have this container, this is one container. Here I am using one manometer. To measure the pressure. Then what will happen? Whatever this fluid is there, manometer, this level will be always same. This level is same. Why? Because it is open. Whatever pressure is here inside this, whatever pressure is inside the container, same pressure is here. Here also PATM, beta. Here also PATM. Clear, beta? In both the places PATM is there. That's why level is same. Correct now? Now please listen here carefully. If I closed this, right? If I closed this with a lid, when I close this, then what will happen? This molecule will add. So when these molecules add, the partial pressure of vapor will increase. So here pressure will be what? Here pressure will be somewhat more than atmospheric. Here inside pressure will be more than atmospheric. Here PATM is there. So because of that, what will happen, beta? Because of that, this will go somewhat here, and this will be something like this. It will be something like this. Now this much difference will come. This is, let's say, H or delta H. A very small change will come. Now this unbalance is because of what? Because of this vapor pressure. So here now what is pressure? That is PATM plus vapor pressure. PVS I'm writing because it's saturated air, right? Please listen here carefully. What you can do that, if you have perfectly fine YouTube manometer, then do one thing, you just put into a put into a glass where water is there and just check that. So very slow, just give some time because this phenomenon is very slow. Evaporation is very slow phenomenon. Just give 1-2 hours. Then after 1-2 hours, you will find that this is somewhat deflection is there. Deflection is there. Why this deflection is coming? Because of the vapor pressure, because inside the pressure will be somewhat more than atmospheric pressure, because these molecules are added, and this will keep on increasing. Here partial pressure will increase until what condition it will increase? Until the air present inside is going to be saturated. जब saturate हो जाता तो process रुक जाएगा. When it will reach the saturation, then process will stop. Clear है बेटा? Process. So what is PVS here? What is PVS? PVS will come rho G delta H. Rho G delta H. This is the additional pressure. This is only called as vapor pressure. And if somewhere pressure will be less than this PVS, then only evaporation take place. Let's say bubble formation is there. Bubble. You may seen that during rain bubbles are forming now. So what is the region of this formation of bubble? Bubble is only going to form. What is there inside the bubble? That is vapor only. Right? Water vapor only, right? So here basically water vapor is there. And when the water vapor will form? When the pressure will be less than vapor pressure. This point is clear, beta. Okay. So now I am going to give you the theory part so that you can write, you can make your notes. So all liquid have tendency to evaporate. We all know that some liquids are evaporating fast, some are evaporating slow. Like water is there. Water evaporation rate is faster compared to mercury. Whereas petrol is evaporating even faster than water. Suppose three liquids you have. One is petrol, water, and mercury. So mercury will also evaporate, but it will be very slow. Evaporation is very slow. Water evaporation will be somewhat more, and petrol evaporation will be faster compared to all these three. Clear hai? Now, so all the liquid have tendency to evaporate if the container is closed. If the container is not closed, then air will never come in saturated state. If container, अरे भैया air कितना है, पूरा बहुत सा air है, you cannot saturate the air. So if it is a closed, then inside a small amount of air is that can be saturated. So the molecule escaping from the surface until the saturation state is reached. This saturation state is also called a phase equilibrium. That is also called as what? Phase equilibrium. What do you mean by phase equilibrium? Phase equilibrium means the liquid will basically, there may be chance that evaporation may take place, but whatever molecule will evaporate, same molecule will condense also, basically, right? So let's say here liquids are there. So at phase equilibrium, whatever liquid will evaporate, right? Whatever to the gaseous phase I am writing, or vapor I am writing better. So this is evaporation, right? Evaporation. And same thing is going to be reversed. Whatever number of molecule will be evaporate, same number of molecules are going to be condensed also. Clear beta? This is at phase equilibrium condition. Clear beta? So this is also written here. Any confusion, you tell me. Any confusion up to here, you tell me. Okay, now clear. Notes I will give you in the group. Okay, don't worry. Now so what is basically vapor pressure? Vapor pressure is defined as a partial pressure partial pressure exerted by the vapor of the liquid which are in phase equilibrium, means saturated condition. Phase equilibrium with the liquid means saturated vapor pressure. Same thing I told. See, this total pressure inside is how much? Total pressure inside is PATM plus somewhat more than PATM. Correct? PVS basically. Right? So the partial pressure exerted by the vapor on the liquid, that is basically called as what? That is basically called as vapor pressure. Please listen here carefully. Suppose one container is there that is closed, inside pressure is, let's say, 102. The pressure inside is 102, right? Now this 102 have two things. Dalton's partial pressure law, you know, right? So here this will be contributed by two things. One is, let's say, 99 is dry air. 99 kilopascal is a dry air, and 3 is basically water vapor, and it is saturated. It is saturated. So what is the partial pressure of water vapor? That is 3 kilopascal only. Don't think that it is a total pressure exerted by the air in the water. No, it is a partial pressure of vapor. अरे भाई सुनो, समझो यार, समझो. जिस रूम में आप बैठे हैं उस रूम में दो चीजें हैं, एक तो ड्राई एयर है और एक वाटर वेपर है. तो टोटल प्रेशर जो हमारे ऊपर लग रहा है कितना लग रहा है? टोटल प्रेशर 101 लग रहा है, राइट? बट उसमें से एयर लगा रहा है 99 और 2 लगा रहा है वाटर वेपर. अब रूम का एयर अगर सैचुरेटेड हो जाएगा तो उसका प्रेशर थोड़ा बढ़ जाएगा. अब मान लो रूम का प्रेशर हो गया 102, सो व्हाट एयर लगा रहा है 99 और पार्शियल प्रेशर ऑफ वेपर कितना है? 3, और वो 3 जो है दैट इज ओनली वेपर प्रेशर. That is also in fluid mechanics mostly we are calling it as a vapor pressure, but in thermodynamics specifically we have to say that it is a saturated vapor pressure. Clear है? हिंदी प्लस इंग्लिश अच्छे से समझ में आता. ठीक है, हिंदी में भी रिपीट करेंगे. I will repeat in Hindi also because many of the people are there who don't know Hindi. That's why. Clear at this point? If the pressure of the liquid at any point in the flow, please listen this point. If the pressure of the liquid at any point in the flow is less than vapor pressure, कहीं पे भी अगर प्रेशर सैचुरेटेड वेपर प्रेशर से कम हो जाएगा तो बबल फॉर्म करेगा. I already told you, means because at that particular place evaporation will take place and then bubble will form. For example, suppose we have this type of thing, right? Let's say we have this type of device. We have suppose this type of device. Please listen here carefully. Please listen here carefully. So here, let's say some fluid is flowing. Here some fluid is flowing. Some fluid is flowing. Correct now? Some fluid is. So you can see that area is decreasing. Right? Area is decreasing. Velocity will increase. Velocity will increase. Pressure will basically decrease. Pressure will basically decrease. So here pressure is decreasing. See here, pressure is decreasing. Please listen here. Area is decreasing. ये आगे समझ में आएगा. When I teach you Bernoulli equation, continuity equation, then you'll understand. A1 V1 is equal to A2 V2. Bernoulli equation is study, then you'll understand. For time being, you understand. As area is increasing, so pressure क्या होगा? Pressure will decrease. Pressure is decreasing, 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 decreasing up to here. So here it will be minimum pressure. Here it will be minimum pressure. Then again pressure will increase, 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 increase. For example, so at this particular location pressure will be minimum. So now if here some liquids are flowing and if here at this throat, let's say pressure is less than vapor pressure. If pressure will be less than vapor pressure, then whatever liquid is there, the liquid will evaporate. Liquid will evaporate, then bubble will form. What will form? Bubble will form. What will form? Bubble will form. And when these bubble will carried out to the high pressure, अब pressure बढ़ रहा है ना, इधर area बढ़ रहा है मतलब pressure बढ़ रहा है. So pressure बढ़ेगा and when it will reach here, then what will happen? Here pressure will be very very high, तो क्या burst हो जाता, it will break, it will burst. When it will burst, then what will happen? Then it will create the cavities. And that phenomena is called as cavitation. इधर देखो, ये डायग्राम समझ में आ रहा है? ये इनवर्ड, ये आउटवर्ड फ्लो टरबाइन का ब्लेड है, अब देखो ध्यान से देखिए, यहां से मान लो वाटर आया होगा, यहां से फ्रॉम हियर वाटर इज कमिंग, आई एम यूजिंग अनदर कलर, from here water is coming. So at this particular moment pressure will be minimum 1. pressure यहाँ पे क्या होगा? At this point pressure will be minimum. So here bubble will form, but bubble will not break here. Now it is moving here, so here area is increasing. अरे वो blades ऐसे है ना, अरे blade ऐसे है, blade is like this, blade is something, one blade is like this, another blade is like this. So here area is increases. When area निकले तो ये bubble यहाँ कैरी करेगा, और जब कोने पे आएगा ना, देखो इधर पेन क्यों नहीं चल रहा जी, when it will come to the corner ना, this bubble will burst and it will create cavities. So that's why देखो, these cavities are not at the center here, it is basically at here. You are getting my point or not? Up to here any problem or not? Up to here any problem? केवल एक चीज समझ लो भैया, बहुत सिंपल है. Now I am going to conclude everything. Please listen here carefully. This 5 minutes is only the important which you have to remember. Only जो मैं पढ़ाया भूल जाओ. Forget everything. Now what I am going to tell you, that only you have to remember. जो मैं ये बोल रहा हूं वही रामबाण है, वही ब्रह्मास्त्र है. How was ब्रह्मास्त्र? Please listen here. Okay. Please listen. देखो क्या हो रहा है. Evaporation is a natural phenomena. Whenever air will be unsaturated, automatically evaporation take place. Evaporation मतलब from the surface molecule will evaporate. If you close the container, then it will evaporate. Pressure will increase, and then it will reach the maximum. Then evaporation will stop. That is called a saturation condition or phase equilibrium condition. At that time, whatever partial pressure will be there, that partial pressure of vapor exerted on the surface of liquid, that is called as vapor pressure or saturated vapor pressure. Now, if somewhere pressure will be in the flow, if somewhere pressure will be less than vapor pressure, then evaporation start hota. Evaporation will start means bubble will form. If this bubble will carried, ये bubble जाता किधर जाता? If this bubble will carry to the high pressure region में जाता, तो ये फट जाता. When it will break, it will burst. When it will burst, then shock waves are going to be produced, and because of that, cavities are going to be formed like this, and that phenomena is called as cavitation. So very, very important question asked by the interviewer, that how to avoid cavitation? How to avoid the cavitation? Sir, it is very, very simple. At anywhere in the flow, the pressure should never go below vapor pressure. The pressure should never go to below vapor pressure. Basically, minimum pressure is going to be at the throat. So throat pressure must be greater than vapor pressure. Throat pressure must be greater than vapor pressure. Clear है this point? बस इतना ही, ज्यादा जानो नहीं. ज्यादा जानोगे तो पागल हो जाओगे. बाकी वॉट एवर कॉन्सेप्ट आर देयर, प्लीज डोंट वरी. साइकोमेट्री पढ़ाऊंगा ना, हवा में बातें करोगे. Huge damage to the part. Up to here any problem? If you understand everything, एक जरा लाल दिल बना दो, लाल दिल. अगर तुमने किसी को दिया ना हो तो, अगर किसी को दिया नहीं है तो आज दिल बना दो. और जो लोग ने बना दिया है वो आग बना दें, क्योंकि उनके पास बस आग ही बचा है अंदर. जल्दी, do it fast. If you understand this concept, do it fast. So to avoid the cavitation, the pressure of the liquid should not be less than vapor pressure. To avoid the cavitation, pressure of the liquid should not be less than vapor pressure at any point. Now next point is, vapor pressure increases with increase in temperature, as I told you, right? वेपर प्रेशर इंक्रीजेज इंक्रीज इन टेम्परेचर, जैसे जैसे टेम्परेचर बढ़ाएंगे उसका वेपर प्रेशर भी करस्पॉन्डिंगली बढ़ेगा। अपोजिट में बोल सकते हैं कि जैसे जैसे प्रेशर बढ़ाएंगे वैसे वैसे करस्पॉन्डिंग सैचुरेशन टेम्परेचर बढ़ता जाएगा। बोथ आर इक्विवेलेंट। नाउ जस्ट नाउ आई टोल्ड that petrol is more volatile. Petrol is more volatile. Why? Because the vapor pressure of petrol is more than water. Vapor pressure of petrol is more than water, hence it is more volatile. Vapor pressure of mercury is very low compared to water, hence it is excellent fluid in the manometric fluid. Why? That I will understand, you will understand. Just note down that this point when I will discuss manometry, then you will understand. Sir, at any temperature evaporation take place? Air must be unsaturated. It will take place at any temperature, that is fine. Rate of evaporation is depend upon the temperature. Who is asking this? Ramakrishna. At any temperature evaporation will take place, because for evaporation temperature is not the key factor. The key factor, air must be unsaturated. If air is unsaturated, then definitely evaporation will be take place, but the rate of evaporation is depend upon temperature. More temperature fast hota, low temperature slow hota. Okay, now please listen here this point. Please understand this point. Suppose we have three liquids. This is HG, water, petrol. Please listen here carefully. बालाजी देखो पीले कलर का दिल दे रहे हैं, क्योंकि लाल कलर का दिल किसी और को दे के आए हैं। Now suppose Hg vapor pressure is, just I am writing some random value, don't say that how can you write wrong data. So it is just make you understand. I don't remember that what is the basically vapor pressure of Hg. I don't remember, because it is depend upon the temperature and all, many condition it is depend upon. So I am just writing one value to make you understand. Let's say this value is 0.1 kilopascal. Just I am writing, don't say that sir is it right or wrong, just to make you understand. Now this value is, let's say, 2 kilopascal. This value is, let's say, अरे जीरो तो रूम टेम्परेचर एट फॉर एच जी, एग्जैक्ट जीरो नहीं होता है, एक्चुअली एग्जैक्ट जीरो नहीं होता है फॉर एच जी ऑल्सो. It will have some certain value, but it's very low. At normal temperatures it is very low. Basically value also I'll tell you, but currently I don't remember the value. At some 20-30 degree, what is the value I do not remember, but I'll tell you in future. Let's say petrol is 5 kilopascal. Just random value I'm taking to make you understand. Now please listen here. If suppose pressure is, if pressure is less than vapor pressure, if pressure will be less than evaporation pressure, then bubble will form, and it will volatile. Now suppose actual pressure is 3 kilopascal. Actual pressure is 3 kilopascal. If 3 kilopascal is there, if actual pressure is 3 kilopascal, then mercury will not evaporate. Mercury will not evaporate, water will not evaporate. Mercury will not evaporate, water will not evaporate, but petrol will evaporate. Petrol will evaporate. You are getting my point? Petrol will have power is gone. So petrol will evaporate. So you can see that these two, suppose pressure is 1 kilopascal. If actual pressure is 1 kilopascal, then petrol will evaporate, water will also evaporate, but mercury will not evaporate. And the evaporation rate of petrol will be more. Why? Because pressure difference is more, na? Actual pressure is 1 kilopascal and the saturation is 5. So 4 different, potential is very high. So more molecule will go faster, right? So petrol will be high volatile. I hope you understand by this one. Clear hai? Sir, will you take the application of thermodynamics before? Yes, Gaurav Mishra, I will definitely take. I will definitely take. एकदम क्लियर राजेश कुमार सिंह, एकदम क्लियर हो गया. Clear at this point? Okay. Now please listen here carefully. One more important information I am going to give you. Whoever is preparing for GATE 2023, right? They need to know that what things they have to study, what not to study, what they have to study, what not to study. Because some topics are there, if you want to leave something, suppose you just want to cover only 80% of syllabus, you just want to cover 80% of syllabus, then what is the portion, what is this 20% that I have to leave? That has some certain criteria. If you leave 30% content, if you leave 30% content, as I am suggesting, believe me, you can attempt more than 80 marks. If you leave 30%, now if you leave 30%, then also you can attempt more than 80 marks, more than 80%. So कैसे, what is the raj behind that? What is the, क्या होता उसके पीछे का राज? मैं प्रॉमिस करता हूं, अगर आप 30% 30% सिलेबस छोड़ देंगे तो भी आप 80 से ऊपर मार्क्स को अटेम्प्ट कर सकते हैं, राइट? नहीं तो मोहित का भी आएगा वीडियो. मोहित नाम उस लड़के का, AIR 53, मोहित नाम है उस लड़के का. 2018 में 53 रैंक पर लाया था 4 महीने पढ़ के 30 to 40% सिलेबस छोड़ दिया था उसने. क्या छोड़ना है ये ज्यादा इंपॉर्टेंट है, क्या पढ़ने से ज्यादा इंपॉर्टेंट क्या छोड़ना. It's even more important than what not to do. Even in life also, see, there are many things to do in the life, many things, right? But you must know what you can't do rather than knowing what you can do. Please listen here again. What I'm saying, that in your life you must know that what you can't do rather than knowing everything that you can do. You can do lot of things, but you may know that what you can't do. You must know your restrictions. Sir, sir, क्या बात कर रहे हैं sir? Impossible word is not there in my dictionary. Impossible word is not there. I can do anything. मैं जो चाहता मैं वो कर सकता. कहां से खरीदी ऐसी घटिया डिक्शनरी? वो चेन्नई एक्सप्रेस का डायलॉग है ना, चेन्नई दीपिका पादुकोण बोलती है कि कहां से खरीदी ऐसी घटिया डिक्शनरी. Impossible word is there, and you must know your limitations. You must know your limitations. अब मैं कल बोलूं कि मैं बॉडी बिल्डर बनने जा रहा, I can do whatever I want and I'm going and start doing body building and start taking proteins, ये वो, पता तबीयत खराब हो गया मेरा. No sir, you can do. अरे रहने दो. It's a 30, मैं 30 or 32 years का हो गया हूं भैया. अब और मेरा वेट कितना है? 60 kg. अब मैं बॉडी बिल्डिंग स्टार्ट करूंगा तो कब करूंगा? लाइफ में यू मस्ट नो व्हाट यू कांट डू रादर देन नोइंग एवरीथिंग दैट यू कैन डू, राइट? सो टुडे at 10 p.m. everyone have to come in that session. If anyone is not coming, I'll kill you, I'm telling you. 10 p.m. today at 10 p.m. special class, free class is there. Special class is there at Unacademy platform. I have already shared the link in our channel Shivam Dixit 63 Telegram channel. At Telegram channel, that is Shivam SHIVAM DIXIT 63, उसमें शेयर किया है. Definitely you have to come and I will share you the key secret. सर YouTube में क्यों नहीं बता रहे? क्योंकि YouTube में बताऊंगा सबको पता चल जाएगा. It's only for you, exclusively for you only. I will lead industrial engineering. आकाश, आज तुम समझ लो, जो इंडस्ट्रियल इंजीनियरिंग छोड़ेगा उसका कभी रैंक नहीं आएगा. If you show me single person, single topper who got top 100 rank, if he say that I left industrial engineering, I will stop teaching. I'm telling you. This is my guarantee. Arey, don't delete the message yaar. ठीक है, it's fine. You are saying your opinion, but I am saying the correct thing ना. तुम गलत हो सकते हो तो मुझे सही करना मेरा काम है ना. If you are leaving this subject, like Akash is saying that, sir, I will leave IMOR. If you leave IMOR, forget about top 100 rank. Forget about top 100 rank, beta. Forget. You cannot show me the single student in top 10 in history of GATE in last 5 years. Last 5 years, if you cannot show me a single person who left IMOR and got top 100 rank. Not a single person. You must know what is the criteria to leave a subject, what is the criteria to leave a topic. कौन बताएगा वो? मैं बताएगा. I cannot watch that full 60 minutes, sir, because I watched already 25 minutes Unacademy today. तो 25 मिनट कर लिए तो आगे नहीं कर सकते क्या? Is it restriction? I don't know actually. Is it restriction that you cannot watch more than 25 minutes? अरे किसी और की आईडी से लॉगिन कर लो. क्या तुम भी ऐसा छोटा मोटा बात आता है तुमको? इतना कॉमन सेंस नहीं है. यू आर एन इंजीनियर. ओके नो सर, कॉमन सेंस नहीं है तुमको. बट यू हैव टू वॉच, यू हैव टू कम, बिकॉज आई विल क्लियर योर डाउट्स ऑल्सो. इफ यू आस्क सर दिस टॉपिक कैन आई लीव, आई विल टेल यू वेदर लीव और नॉट. If this I study, I will tell you whether I study to not. 10 बजे ये सेशन अगर sir, yes, we cannot find more than 60 minutes in a day. Okay, okay. ठीक है, ट्राई करो. जो भी तुम पूछोगे सब मैं बताएगा. कौन बताएगा? मैं बताएगा. मैं कौन? शिवम दीक्षित, द शिवम दीक्षित. ओके, चलो. तो वेपर प्रेशर हुआ खत्म, राइट. अब आते हैं अपने मोस्ट इंपॉर्टेंट टॉपिक, दैट इज सरफेस टेंशन. सरफेस टेंशन, सरफेस टेंशन. जिसने भी सेशन को लाइक नहीं किया उसको मैं भी गोली मारता हूं. रुको 1 मिनट, अभी गोली मारता हूं. मेरा पिस्टल कहाँ है? पिस्टल उठा के ऐसे गोली मारूंगा, मेरा कैमरा टूट जाएगा. ओके, कुछ फिगर्स दिख रहे हैं तुमको, कुछ डायग्राम्स दिख रहे हैं, राइट. नाउ दिस डायग्राम्स आर वेरी वेरी इंपॉर्टेंट फॉर दिस डिस्कशन. this concept is very very important. Why this is very very important? Because interview में they will ask about the surface tension. Sir, I studied in 12th standard that what is surface tension, but I'm damn sure you don't know. You don't know what is surface tension. If I ask you why it is defined as a line force, then you will not say what is that. Is it defined as a tension in is acting on the surface? Then how it is perpendicular to the surface? It is acting perpendicular or parallel to the surface? सर नहीं समझ में आया क्या पूछ रही. Just wait. Now few experiment you need to do. First thing is you can see first diagram. This is a first diagram. In first diagram, if you see, generally we see that if any metal piece is there, na, if I put into the water, then it will sink in the water. It will sink. डूब जाता in water, but it is not going to sink, right? If you are putting one very thin small pin of metallic pin in a water, then it is start floating in the water. Why? This is first question. Second question, the dew जानते हैं? dew समझते हो ना? Ose. So generally you see that this ose is basically what? Spherical in shape. Why it is always in spherical in shape? Why it is in always in spherical in shape? Third point you say ये तो किया होगा. Have you did this during your childhood? Blow this bubbles. So when you are this diagram को बहुत ध्यान से देखिए. डायग्राम्स को बहुत ध्यान से देखेंगे. अगर ये डायग्राम नहीं दिखे ना, ये डायग्राम में कितनी मुश्किल से निकाला गूगल से हैं ना. इधर से now is it spherical in shape? Is it spherical in shape? No. Is this one is spherical in shape? No. But after some time this is spherical in shape. What I am trying to say, when you are blowing, then at that time some random shape is there, but after some time automatically it is coming to the spherical shape. Automatically it is coming to this bubble, soap bubble. क्या बोलते हैं इसको? Soap bubble. Now please listen here carefully. When you are blowing it, at that time it is not directly spherical, but after some time automatically it is coming to the spherical. You can see that. Closely observe करो, closely observe करेंगे, right? Now third point, how it is crawling. This, right, ये crawl करता है ना, ये insects crawling on the water. How it is crawling, right? Why they are not going to sink? How they are able to crawl? That is one question. Now come to here. This diagram is also very important. This diagram is also very important. Now you can see that this is not exactly spherical in shape. This is not exactly spherical in shape. This is not exactly, but when he dropped finally, then it is in spherical shape. The tab and a tab, when water is coming out from the tab, then देखो, the water is adding, and this bubble, this droplet, drop size increase, after some time it will cut from there, and it will become spherical. Now one very important experiment I am telling you, one very important, ये तुमको मिल जाएगा, ये 2 syringe लेके आना है. क्या लेके आना है? 2 syringe. Just take 2 syringe, right? Just take 2 syringe. In one syringe take water, pure water. One syringe you take pure water. One syringe you take water with surfactant. Surfactant मतलब detergent. डिटर्जेंट घोलो और उसमें वो वाटर, जो डिटर्जेंट वाटर है, उसको इसमें ले लो. अब तुम्हारे पास क्या है? व्हाट यू हैव? You have 2 syringe. In one we have pure water, one we have water plus detergent. Now you have to make it like this. Now you just start pressing it slowly. Slowly. Then what will happen? Then here droplet will come out. Just observe that droplet. Then do the second also the same. Just start pressing from here. Then droplet will come out. Just observe that droplet also. What difference you will got in both the droplets? If anyone tell, I will give you the chocolate now itself. It's a chocolatey problem. Just now you will get chocolate in your home delivered, or maybe Google Pay you will get. चॉकलेटी प्रॉब्लम, वन चॉकलेटी प्रॉब्लम. अब कुछ लोग तो एक्सपेरिमेंट करने निकल लिए हैं, सर एक्सपेरिमेंट करके आता हूं तब बताता हूं क्या डिफरेंस है. आई जस्ट वांट द डिफरेंस. तन्मय बारी, अक्षय राहुल, यू आर कमिंग वेरी लेट बेटा. Why you are late? Soap bubble have 2 layers. Wrong bhaiya. It's a droplet only. Both droplets are there. Only droplet, no 2 layers. Ramakrishna, it will be droplet only. अरे blow नहीं कर रहे हो भाई. It is not like you are blowing. You are just dropping it. Water droplet will be bigger in size compared to soap droplet. तुम मेरे ऑफलाइन के स्टूडेंट हो ना? धनंजय मिश्रा, how you get to know this? You are my student now, old student now, I think so. Bala, soap water has less bond. Wrong भैया. And how you will observe the bond? एक्सपेरिमेंट करते हो, बॉन्ड में तुम्हें नजर चला जा रहा है. You are very, you are God or something. How can you see the bond? Soap water has less bond बोल रहा. How you will be able to see the bond? I am saying that you just observe and tell me the observation. ऐसे वाटर लेंगे, वाटर का बबल देखेंगे, वाटर का ड्रॉपलेट देखेंगे, नॉट बबल, ड्रॉपलेट देखेंगे. Then we'll see the this डिटर्जेंट का ड्रॉपलेट? नो सर, बट हाउ देन यू नो दैट धनंजय? यू आर वेरी टैलेंटेड, you are very talented. Only Dhananjay Mishra is giving the correct answer. Only Dhananjay Mishra is giving the correct answer. If you take, please listen here carefully. If you take beta, listen here. If you take two, basically what, two syringe and one water is there, pure water is there. Another one, what is there? Another one is a detergent is there, right? If you start pressing it, then you'll just observe the droplet, then you'll find that water droplet will be big and detergent droplet is going to be small. Detergent droplet is going to be small. So finally Dhananjay Mishra won the chocolate. So he gave the correct answer of chocolatey question. So Dhananjay Mishra, you will get one chocolate. So do one thing. You just go to the one shop is there nearby your home. Nearby home one shop is there na. You just go to that shop and say that I want one chocolate. So you just bring one chocolate from him and tell my name. Tell my name. Please listen here again. Tell my name and my code also. Shivam 101. What you have to do? You have to take one chocolate. You have to tell my name, my code Shivam 102, and you have to pay the money for chocolate and come back. This is the option. Okay, Dhananjay, I think adding soap decrease the surface tension. Yes. Water droplet ground reaches very fast. ये देखो फरीद भाई तो अलग ही गेम में चल रहे हैं. इतनी देर में एक्सपेरिमेंट करके वो आया और फाइनली बोल रहा है कि जो वाटर ड्रॉपलेट है वो जल्दी ग्राउंड पहुंच जा रहा है. हे भगवान. Dhananjay Mishra, you got how to get the chocolate? You got that how to get the chocolate? So all these answers, who is going to give? I am going to give all these answers. So why all these things are happening? Why all these things are happening? Please listen here. This is very, very important concept. Only teach by me. Now, to understand this concept, let's understand what is the origin of surface tension. What is the origin of surface tension? Suppose we have some liquid here, right? We have some liquid, okay? We have some liquid here. Please listen here carefully. We have one liquid here. So now I am going to consider one molecule at the below. Here I am considering one molecule A. Liquid molecule only. So I am considering one molecule. So this molecule A is surrounded by different molecules. So here also one molecule is there, here also. So everywhere molecules are there, right? It is surrounded by different molecules basically, right? So here one molecule is there, that is also applying coercive force, attraction force, coercive force, attraction force, coercive force, coercive force, attraction force. So this is basically balanced. This is basically what balanced. Now if I take one molecule here, then what will happen? This side one molecule is there, this side one molecule is there, this side, but here no molecule is there basically, no liquid molecule is there. So basically you can see that in molecule B, net downward force is there, Please listen here again. ये चॉकलेट नहीं मिला, इलिटरेट इंजीनियर मिल गया भैया. तुम दुकान में जाओ तो you just go in the shop और बोलो कि भैया मुझे 100 रुपए वाला सिल्क चॉकलेट दे दो. शिवम सर ने बोला है, उनका कोड है शिवम 101, ये लो 100 रुपए और चॉकलेट लेके आ जाओ. दैट्स वेरी सिंपल. Very simple. Now listen here. So I have some fluid, basically I have some fluid. Now I am taking one molecule A which is inside the fluid. So around that molecule A different molecules are there. So चारों तरफ से क्या हो रहा है? Intermolecular forces are there. So it is a balanced condition. By you just assume that you are at one particular condition, and you are one particular condition, you have many girlfriends, many girlfriends, and they are they are stretching you basically, right, from all the directions. एक ऊपर से बाल पकड़ के खींच रही, एक हाथ पकड़ के खींच रही, एक दूसरा हाथ पकड़ के खींच रही, एक आगे से खींचे, एक पीछे से खींच, then you will be in balanced condition, you will not move anywhere because it is from all the side, right? So it is, so molecule A is in equilibrium, that I understand, but what about B molecule? In B molecule, from this side is fine, this side is fine, from bottom also someone is pulling, but top nothing is there, so net downward force is there, so it have to go down automatically, it have to go down because net downward force is there, but still it is not going down. ये नीचे नहीं जा रहा, क्यों नहीं जा रहा मुझे समझ में नहीं आ रहा, that is my question. I am saying that A is not moving from their place, I can understand, because from all the side, this attraction force is there, but what about molecule B? In molecule B, net downward force is there, but still it is not going down. Why it is not going down? Because at the surface beta one membrane is formed. Sir, what about prep ladder student? They also can come and join. Even though I have taught all these concepts in prep ladder app, right? But still any confusion is there, you can come, and you can come in a special class also, free special class also. Here I am going to plan, here in YouTube I am going to plan the crash course for all the subjects, so you can attend, no problem. Please listen here carefully. So the B molecule है, B molecule net downward force is there, but still it is not going down. Why? Because here also one molecule is there, here also one molecule is there, here also one molecule, here also one molecule. So basically one membrane is formed. Sir नहीं समझ में, membrane क्या होता है sir? I did not understand sir. No problem. Suppose I have here one building is there, here one building is there, here another building is there, here another. Please listen here carefully. Chapak, hey hello Chapak, क्या कर रहा है तुम मोबाइल को देख के उधर? फेसबुक चला रही? I'll kill you. You don't know me, I am very dangerous. I look cute, but I am very dangerous. I look like Virat Kohli. Virat Kohli look like me. That's why he put 100 recently. So now here one person is there. It is something like this. Okay. Here one person is there. Here another person is there. Correct. Now you see, so these people are not going down. These two people are there who are basically sleeping, or who are basically laying down, लेटे हुए कहाँ पे, छत पे, right, at the roof. They are लेटे हुए, right, but they are not going down because obviously building is there to support them. Building is there, right. Now here one person is there, here one champak is there, here also one another champak is there, right. Now but he is also not going down because now देखो membrane दिख गया membrane. Can you see the membrane? Now see here, for these two champaks, downward force is there due to gravity, but still they are not going down. Why? Because one membrane is ऐसे हाथ पकड़ के रखा हुआ है, ऐसे हाथ, right. Now in their hand, is there any tension or something? Obviously tension is there. Here obviously tension is there. You are getting my point or not? This is only the concept of surface tension, and that is defined in a line. Maybe some other line is there, right? So this is one line. So it is defined as a line force. Or another example I can say that, suppose you just consider that here one string is there, right? Here some string is there, right? Now in this string, सर खतरों के खिलाड़ी हैं, राइट? In this string, suppose some downward force is there. If some downward force will be there, F net downward force, then what will happen बेटा? ये क्या हो जाता? ये थोड़ा ऐसे हो जाता. अब देखो, ये है तो यहाँ पे टेंशन, यहाँ पे क्या है? Now here we have a tension, बट इसका ये तो किसी एंगल पे है. सो वन कंपोनेंट ऑफ द टेंशन, वन कंपोनेंट परपेंडिकुलर कंपोनेंट ऑफ दिस. अरे ये कैसे लग रहा है? सरफेस इज नॉट एक्चुअली हॉरिजेंटल परफेक्टली. You will not able to visualize it because that angle is very, very small, but actually it is slightly like this. It's slightly like this. So what will happen? The surface is something like this. Hands कैसे रहते? ऐसे रहते. कभी भी ऐसे हैंड करके नहीं हो सकता. It's not possible. ऐसे नहीं हो सकता. It's not possible कि ऐसे करके पकड़ लिया. It will be always like this. When it will always like this, so this is the angle. This is the angle. Now, if this theta angle is there, so it have two components. One is horizontal component, one is vertical component. और vertical component किसको बैलेंस करेगा? नेट डाउनवर्ड फोर्स को. वर्टिकल कंपोनेंट किसको बैलेंस करेगा? नेट डाउनवर्ड फोर्स को. हैव यू अंडरस्टैंड दिस कॉन्सेप्ट? हैव थोड़ा थोड़ा लॉजिक आया? अभी बहुत कुछ बाकी है. स्टिल लॉट ऑफ थिंग्स आर रिमेनिंग. थोड़ा थोड़ा समझ में आया? अगर समझ में आया तो दिल बनाओ. पहले दिल बनाओ. जल्दी जल्दी जल्दी, फास्ट, जल्दी दिल बनाओ. थोड़ा थोड़ा समझ में आया? The A molecule A is basically in balance condition, no problem, but the molecule which is on the top that had net downward force, but membrane is there, surface tension is there. One component of that force in vertical direction is going to balance the net downward force. That's why it is not going down. आदर्श, मजा आ गया सर. अच्छा राहुल, यस. बालाजी, इलिटरेट इंजीनियर ने का दिल ही काला हो गया. कितना सिगरेट पीते हो जी? हैं? इलिटरेट इंजीनियर जो है और काला कलर का दिल दिखा रहा है. सिगरेट पी पी के काला कर लिया दिल को. ओके, नो प्रॉब्लम. यस, वेरी गुड, परफेक्टली फाइन. बेटा ऐसे कॉन्सेप्ट ना अच्छे समझा नहीं पाते. और अगर मतलब ये बहुत शॉर्ट में पढ़ा रहा हूं मैं अपने हिसाब से बहुत शॉर्ट में बहुत फास्ट पढ़ाने की कोशिश कर रहा हूं, नहीं तो मजा ही आ जाता. Now the second point, listen here. Now basically, so liquid surface है, ऐसे surface है, but surface tension is defined in a straight, like in a line. देखो, this is one line in the surface, This is another line in the surface. This is another line in the surface. नहीं पीता सर, अपने कलर नहीं बोला था. ओके, हार्ट बोला था. ओके, हार्ट, इट्स हार्ट. ओके, now please listen here carefully. Now this force is basically defined for per unit length. See, okay, it may be any length now. So whatever force is required to maintain the unit length, it is maintained to unit length. Downward force लग रहा है ना, उसमें unit length को maintain करने के लिए whatever force is required, that force is called as surface tension. देखो, maybe this building is very big, right? Let's say something like this. I will make you understand. Suppose another building is somewhere here. So here one person is there, here another person is there. Now you see, So it is defined in one particular length. Maybe another building parallelly, another building, another people are there. In parallel, another building, another people are there. But I am going to talk about only in one line. In one line also, this line maybe 10 meter long. Right? This may be 10 meter. But I am going to define for 1 meter. So in 1 meter, how to sustain that, how much amount of force is required, that is basically called as surface tension. What is surface tension? Sigma is equal to F by L, Newton per meter. Newton per meter. Clear beta? Clear beta? This point is clear. Okay, first you draw all these diagrams. Now I'm whatever I told, I'm going to explain here. Whatever I told up to now, whatever I told, that is written here so that you can make your notes. मैं notes का भी ध्यान दे रहा हूं, इसलिए मैं सबको लिखने बैठूंगा, बोर हो जाओगे तुम. I'm only explaining, notes are already typed. टाइप करने में कितना मेहनत लगा पता है? मैं मैकेनिकल इंजीनियर हूं, ऐसे ऐसे बटन दबाता हूं, ऐसे ऐसे A B B D, ऐसे से थोड़ी चलता मेरा हाथ. Consider a molecule A which is below the surface of the liquid. The molecule in the influence of various coercive force from all the direction, and it is in equilibrium. Now consider molecule B which is on the surface of the liquid. This molecule is under influence of net downward force because of this. This seems to be a membrane. Membrane is formed which is in tension. One membrane is formed which is in tension, can resist this small force. This membrane can resist this small downward force. बहुत small है, इतना small है कि तुम सोच भी नहीं सकते. Molecular force है भाई. The property of the liquid surface, film to exert a tension is called surface. It means actually the surface is in tension. But one component of that tension is going to balance this net downward force. So it is what surface tension? It is force required to maintain the unit length of the film in equilibrium. That is sigma is equal to F by L. Don't say the F by A, F by L, Newton per meter. It is a line force. Why it is line force? Because it is defined per unit length, and expressed as a force per unit length drawn on the surface. देखो, drawn on the surface, and it acts normal to the line in the plane of the surface. जो surface है उसके normal काम कर रहा है, क्योंकि normal काम करेगा तभी तो उसको balance करेगा. You are getting my point or not? देखो भैया, if suppose this string is there, बेटा ये point बहुत important है, कोई नहीं समझा पाएगा तुमको जिंदगी में कि भैया ये भाई है तो surface का tension पर balance कर रहा है net downward force. How? It is a surface tension, it is a surface force, but how it is going to balance the downward force? Because when net downward force will come, just take the example of this string, then it will be something like this, not this much, right? So now you can see that if I draw a surface line, right, from here, let's say this is surface. So this is what from horizontal. Now please listen here. This is, let's say, theta. This is, let's say, theta, very, very small, infinitely small. Then one component of, so one horizontal component will be there, one vertical component will be there, one horizontal component will be there, one vertical component will be there. So the vertical component of this force is going to balance the F net. It is a line force and expressed as a force per unit length drawn on the surface and act normal to the line in the plane of the surface. Clear hai? Sir, what is a Reynolds number and when spread is injected? Series question. अभी रेनॉल्ड नंबर पढ़ के क्या करते तो पहले बोलो. हम बात कर रहे हैं सरफेस टेंशन की, तुम बात कर रहे हैं रेनॉल्ड नंबर की. वेट करो हर्ष गौतम, जस्ट वेट. See, here everything is going to be in systematic manner, but if you want to do the topics by your own way, or you want to practice in your own way, then I'll suggest you to go and take the subscription, and always use the code Shivam101 and 20% off is going on. 20% off, right? Very big discount is going on. Okay, serious question please, no मजा. हेलो, एक डाउट है. यस, टेल मी. Will flowing fluid experience surface tension? Yeah, surface tension is the property of surface. It will be there for that only. Surface है तो रहेगा. Clear है बेटा? For flowing fluid also surface tension will be there. But we are not considering all these forces during our analysis, because surface tension and all these properties are molecular forces, very very small. Coercive force, it is because of what? Unbalanced coercive force. So that is very very small beta. इतना small है कि किसी भी analysis में consider ही नहीं करना. No need to consider at all. Clear है? Next point. Now I am going to give you the another examples. Now I'm going to do, अभी देखो सारे आंसर नहीं हुए. Now still some of the answers are remaining. Now when you see, first come to this diagram. Now when you see that here this bubble is not exactly in spherical shape, right? So we are adding the mass, it is in being bigger. After some time it will be drop and it will become spherical. Or you can take this example. Here you can see that this bubble is some random shape. This bubble is some random shape, but after some time it will become spherical. How? So I am going to give this answer first. Now I am going to give this answer. All the answer now I will give you one by one. One by one I am going to give you all the answers. Suppose some droplet is coming out from the tab, something tab or maybe a bubble or whatever it may be. So let's say it is a droplet which is a random shape. This is some random shape of droplet. Initially the drop shape is like this. Initially some random shape is there. Drop का shape क्या है? Random shape. Now it have number of molecules बेटा. सर गेट के मॉक पेपर कहाँ मिल सकते हैं? अरे उसमें ही पड़े हुए हैं, मेरे टेलीग्राम चैनल में जाके ले लो. सर आई एम फ्रॉम ASPM batch 1 2020 GATE. You taught thermodynamics there. Thank you. It was best days. Missing you. Ravi P. डोंट वरी, जितना थर्मोडायनेमिक्स में मजा आया था ना उससे कहीं ज्यादा मजा आने वाला फ्लूइड मैकेनिक्स में. डोंट वरी, जस्ट अटेंड ऑल द क्लासेस. सर आप कितने ऑक्सीजन लेते हो? आपकी नोस्ट्रिल बहुत बड़ी. तुमको हम बहुत मारेंगे यार. तुम क्या देखने आए हो जी? यहाँ पे मेरा चेहरा देखने आए हो? कितना ऑक्सीजन लेते हो बताओ. अब मैं कैसे मेजर करूं? ओके नाउ लिसन हियर. तो कैमरा का सेटिंग इतना अच्छा है, मैं इतना हैंडसम हूं यार. ओके नाउ लिसन, प्लीज लिसन हियर केयरफुली. सो लेट्स से one liquid droplet is there. That liquid droplet is random in shape. So at the surface what will happen? Number of molecules are there. Number of molecules are there. ये कोई नहीं पढ़ाएगा दुनिया में. Listen here, एक number of molecules are there. So what will happen? Every molecule has some downward force. अरे surface पे है ना, it will be surface, so net downward force रहेगा ना, right? All the molecules at the surface have net downward force. So this have net downward force. समझ में आ रहा है? देखते जाओ, अभी देखो मजा आ जाएगा तुम्हारी जिंदगी में. इतना मजा तुमने कभी देखा नहीं होगा. Net downward force. So after some time, अब देखो ये क्या कर रहा है? These molecules are try to come closer. So what will happen? This will come in shape of minimum surface area. For given volume. So for given volume, which shape have minimum surface area? For given volume, which shape have minimum surface area? That is sphere. After some time, it will become spherical. समझ में आ गया? कितना इजी समझा दिया सर आपने. देखो एक रैंडम शेप है, उसके अंदर बहुत सारे लोग हैं, they are pulling it, right? After some time what will happen, it will come spherical shape, because sphere have minimum surface area for given volume, spherical shape का surface area less होता है and the surface tension causes the sphere. Yes, if you could an animal what would you be? हर्ष गौतम, मैं एनिमल क्यों होता, तुम एनिमल होते जी, मैं एनिमल क्यों होता, मैं जो हूं वो हूं, राइट? मैं इतना आगे का नहीं सोचता गौतम बेटा, मैं इतने का नहीं होता। हर्ष गौतम, ब्लॉक करो इस हर्ष गौतम को, हर्ष गौतम और कॉमिक वॉइड को ब्लॉक करो। किसी फैकल्टी ने पैसे दिए क्या इधर कमेंट करने को? है पढ़ाई लिखाई कर लो, ठीक है? ये फैकल्टी के चक्कर में पढ़ोगे ना, जिंदगी बर्बाद हो जाएगा। या तो फैकल्टी जिंदगी बना देगा या तो बर्बाद कर देगा, बोलेगा जाओ उसके वीडियो पे कमेंट करके आओ, जाओ। फिर तुम कमेंट करोगे, मैं इग्नोर मारेगा, तुम कमेंट करोगे, मैं इग्नोर मारेगा, तुम कमेंट करोगे, मैं इग्नोर मारेगा। मुझे हर महीने के लास्ट में मेरे अकाउंट में पैसे आ जाएंगे, तुम्हारी जिंदगी बर्बाद। वेरी सिंपल लॉजिक। यू आर गेटिंग? डू यू बिलीव इन एलियंस? देखो ये कितना पैसा मिला भाई तुमको, हैं? डू यू बिलीव इन एलियंस? यू आर देयर ना? After seeing your comments, I start believing on aliens. Okay, forget about these type of people. Team, if you can listen me, please block this Harsh Gautam. Sir Manoj sir एलन है, उन्होंने बोला है मुझे यहाँ आने के लिए। काहे लिए झूठ मूठ बोल रहे हो? सर एक फनी कमेंट के 100 रुपए मिल रहे हैं अनअकैडमी से। तुमको तो कुछ नहीं मिल रहा बेटा, तुमको तुम्हारा करियर बर्बाद किया जा रहा है। दैट्स इट। ओके, नाउ लिसन हियर, स्टॉप दिस फेक आईडीज। दिस इज ही इज नथिंग बट वन फैकल्टी ओनली, आई एम टेलिंग यू, he is nothing but one faculty only in other institute, and he is just coming with some different name and he is doing comment this nonsense comment. Okay, forget about these people. Okay, now please listen here. So now you can see that if suppose some liquid droplet is there, so at surface some molecules are there, they are pulling it, right? They are pulling it, so after some time it will come to the spherical in shape, right? It will come to the spherical in shape. Now listen here, very very important point. See, this bubble is basically, this bubble is seems like what it is a one very important concept I'm going to tell you, very very important concept I'm going to tell you, that the bubble is just like a balloon. Whenever liquid bubble is there, liquid bubble, sorry, either you say bubble or you can say liquid droplet, whatever it may be. Let's say liquid droplet first. So liquid droplet, if you have some liquid droplet, it will be basically look like a droplet for you. For other people it will be droplet, for you it will be balloon. It will be balloon. In balloon, if you see, the surface is stretched, here also the same thing is there. In case of liquid droplet, the surface is stretched, the surface tension is there is a tension in the surface. You are getting my point? There is a surface tension is there. Okay, now please listen here carefully, everyone please focus on this particular point. Now when people will start pulling it, then obviously inside pressure is going to increase. Here pressure is PATM, here pressure is PATM, right? Here pressure is PATM. Now inside pressure is going to be somewhat more na. Here pressure will be how much? PATM plus delta P. Why? Because of this surface tension. This excess pressure is because of surface tension. अरे देखो ना, very simple logic है भाई। balloon है, inside the balloon surface is stretched, and inside the balloon pressure is always more than surrounding. Now generally the pressure, the stretching power or elasticity of balloon is much higher than liquid, but you can make analogy. So whenever a liquid droplet you see na, then other people will say it is a liquid droplet, you say it is a balloon. It is a balloon. Balloon means its surface is stretched, surface, in that surface tension is there, correct? Surface tension will be there, and because of that it will try to maintain its minimum surface area that will be spherical in shape. One very important point, the pressure here will be PATM plus delta P. PATM plus delta. So what is this extra delta P? What is the extra delta P? That we need to find out. Clear hai beta? Just note down these points. Now मैं इस पागल का कमेंट पढ़ लेता हूँ. मिशन करना है क्या बोल रहा है जो देखें. Sir, when you will take the class after Dhanteras. Sir, please block these type of unsaturated people. My pressure toilet. बताओ इतने सारे लोगों को पैसा दे देंगे. Sir, on serious note, you are a good teacher, habit and is fluid and me only do business and earn money like something. Okay. Harsh is saying that, sir, you are teaching very good, but this I am doing because of this is my business. I am going and doing this all this nonsense and getting some money. 296 अपना this. Okay. Hi sir, are you single? आज कितने सारे लोग आ रहे हैं भाई. Are you single? नेटवर्क मार्केटिंग वाले यहाँ भी आ गए. बाप रे बाप. अरे भाई जो लोग पढ़ रहे हैं उनको पढ़ने दो, बद्दुआ लगेगी तुम्हें यार. बहुत सीरियस बच्चे आते हैं मेरी क्लास में. ट्रूली स्पीकिंग, in my class very serious students are there. If you are really faculty by your heart and you are commenting on my sessions, so I request you, I really request you, if you are a genuine faculty, I'll request you don't do all this nonsense, because it is going to harm the student only, right? These people are really very serious. You just go and check the comments. They are doing all the proper comments whenever it will be required. They are giving answers. They are coming on particular time. They are studying very seriously. So if you are really teacher, तो तुम्हें मम्मी क्या कसम है अगर इस तरह के कमेंट बाजी की तो. ओके, मत करो यार ऐसा. जाओ यार अपना काम करो जाके. तुम्हारी वजह से मैं गंदा थोड़ी पढ़ाने लगूंगा. तुम अच्छा पढ़ाना सीखो यार. इफ यू वांट टू बी अ गुड फैकल्टी ना, you learn how to teach. You just improve your content rather than coming in other teachers platform and commenting all this nonsense. Waste है यार. Time waste मत करो अपनी life का. If you want to be good teacher, just enhance your ability to teach. Just enhance your content day by day. Believe me, you will be a good teacher. But by commenting all this nonsense thing, you will never be a good teacher. Okay. Now please listen here. So effect of surface tension. Now I am going to talk about the effect of surface tension. So when liquid droplet is separated initially from the surface of the liquid, then due to surface tension there is a net inward force. There is net inward force exerted over entire surface of the droplet. Entire surface of the droplet, which causes the surface of the droplet to contract from all the sides. Same जो मैं बताया ना, this is this one, right? Same, it will start contracting from all the sides and results in increasing the internal pressure. So यहाँ का pressure क्या हो जाता है, बढ़ जाता from PATM. So it will be PATM plus delta P. So we need to find out what is this delta P. We need to find out. Outside pressure is PATM. Inside pressure is somewhat more. So this extra pressure, excess pressure we have to find out. We are not going to find out the pressure inside the balloon or pressure inside the droplet, pressure inside the bubble. No, I am going to find out the pressure, excess pressure inside the balloon. Okay. Now, now please listen. Which causes the surface of the droplet to contract from all the side and result in increasing the internal pressure within the droplet continuous till the force due to surface tension is balanced with the internal pressure and the droplet from the sphere, which shape of the minimum surface area. So that I already explained. Now hence the liquid droplet is spherical in shape, right? Always it is. Why it is in spherical shape? I hope you understand. To reduce the surface area. To reduce the surface area, and internal pressure is more than external pressure, and the excess pressure is balanced by surface tension. See, PATM is balanced. Suppose inside pressure is somewhat more than PATM. Inside pressure is somewhat more than PATM. So PATM is balanced, right? But inside pressure is somewhat extra. Delta P is extra. So this delta P extra is balanced by what? Surface tension. This delta P is because of what? Surface tension. So obviously it is balanced by what? Surface tension. Correct na? So surface tension can be defined like this also. Surface tension can be defined like this also, the liquid by the virtue of which liquid tends to minimize its own surface area. Liquids try to minimize its own surface area. Clear at this point? Clear hai? Clear hai beta? Now next. Okay. Now here I told you that the size of droplet is also determined by the surface tension. देखो मैंने एक experiment कराया था. I did one experiment, right? In that experiment you find that the water droplet was big. Water droplet is big and the droplet of water plus detergent, that was small. Even if you put mercury, so mercury droplet will be much bigger. Mercury droplet will be much bigger than water also. Why? Because see, it is depend upon the surface tension. See, suppose here you can see that whenever this water is coming from the tab, ना जब tab से water आता है, just observe it closely. Observe करो, क्या देखोगे? Droplet is increasing, area increasing, right? Volume increases, size increasing. After some time it will cut from there, right? वो नीचे गिर जाता. It will increase और फिर क्या हो जाता? Cut हो जाता. Why it is happening? Please listen here. See, its mass is adding, so size is increasing, weight is increasing, mg is increasing, and that is going to balance by surface tension. After certain limit, mg will be more and surface tension will not able to hold it. So it will break down. Now, suppose take the example of mercury and water. So what is going to happen? Mercury surface tension is more, so it can handle or it can sustain more mg. More mg means the bubble size will be big. Droplet size will be big. Mercury droplet size will be big because it can handle more. You are understanding. Water surface tension is less. Water surface means its size will be small only because it can sustain less mg only. Whereas when you are adding surfactant, when you are adding detergent, then surface tension is reduced. Why we are using this detergent? Detergent is used so that the surface tension will reduce. If surface tension will reduce, then these water can penetrate easily and it can remove the dust. Now here you can see that when it is a pure water, surface tension was more. Surface tension more means it can hold more mg. Here you can see if detergent you are adding, then surface tension decreases, it can hold less mg. If suppose somewhat mercury is there, mercury surface tension is very, very high, so it can hold more mg, so it will be bigger. Basically, clear hai beta? This point is clear. So that point only I wrote here, right? So you just note it down. Surface tension determines the size of the liquid droplet that forms. A liquid droplet that keep on growing, जब देखते हो droplet को, जब वो टैप पे गिरता है, keep on growing by the addition of the more mass, breaks down when the surface tension can no longer hold it together, right? वो तो ड्रॉप बढ़ता जा रहा है, जब ड्रॉप का वेट इतना ज्यादा हो जाता है कि सरफेस टेंशन हम उसको होल्ड नहीं कर सकता, तो उसका क्या होगा? वो ड्रॉप नीचे आ जाएगा. सो दिस इज लाइक अ बलून. बलून में क्या है? आप हवा भरते जा रहे हो, बढ़ता जा रहा है. एक टाइम पे ऐसा आएगा कि प्रेशर ज्यादा हो जाएगा और फट जाएगा, अलग हो जाएगा, राइट? सो सेम थिंग इज हैपनिंग हियर आल्सो. क्लियर है बेटा? क्लियर है? ओके, नाउ वन मोर थिंग. The surface tension is basically due to what? Due to unbalanced coercive force. Coercive force की वजह से नहीं होता है. Surface tension is not because of coercive force. अरे coercive force is here also. Here also coercive force is there, but surface tension is not here. It is because of unbalanced coercive force. Here because of unbalanced coercive force. Please remember the unbalanced coercive force. With increase in temperature, coercive force will reduce. With increase in temperature, coercive force will decrease. And coercive force will decrease with surface tension is also that's why if you wash your clothes with warm water, if you wash your clothes by warm water, then what will happen? Surface tension will reduce. Surface tension will reduce, and then right, it can remove the dust easily. Clear, beta? Okay, so this is all about today's class. And this part, that excess pressure inside the liquid droplet, I will teach tomorrow, and these questions also will do tomorrow. So tomorrow this chapter will be over, and next chapter also will start. Clear, beta? Any doubt? First you ask me. अरे यार शिट, इसको डिस्कार्ड कर दिया, जो लिखा था वो डिस्कार्ड हो गया, सॉरी. ओके हर्ष और रसिया टेम्पो. अरे यार क्या पागलपन कर रहे हो, जाओ अपना काम करो जाके. Okay, if anyone have any doubt, please, now I have 5 more minutes. Ukraine versus Russia, देखो क्या पागल हो. Okay, if anyone have any doubt, you can ask. जाओ बेटा, मेरा क्लास तो खत्म हो गया. Mr. Hers and Comic Void, my class is completed. Go and start doing all this nonsense in someone else's class. जिंदगी में यही करो, ठीक है. मेरे अकाउंट में पैसे आ जाएंगे 30 को. तुम देखो तुम्हारे में हाथ देता है कि नहीं देता हो फैकल्टी. तुम तो फैकल्टी हो, कहीं कुछ हो नहीं रहा तुम्हारा, जिंदगी भर ऐसे ही रहोगे तुम. Can you please explain the relation between surface tension and washing clothes and water? See, if surface tension will be more, right? If surface tension will be more, then bigger droplets will form, or more number of molecule will be there together. If surface tension will be more, then more molecule will be there together, so they will not able to penetrate the cloths. It will not able to penetrate the cloth easily. If suppose warm water is there, if water will become warm or hot, then the surface tension will reduce, so the corresponding size will also reduce. So if size will reduce, then it can penetrate the cloth easily. Even if you are adding detergent, that is also a surfactant. Surf excel suna hai na? So surf excel, in surf excel, surf is basically from surfactant. Actual name is surfactant, right? So surfactant अगर add करते हैं, detergent add करते हैं, then its surface tension will reduce. Smaller size will be there, it can penetrate easily. And everyone have to come today. Today, don't forget, link I already shared in our special class. Everyone have to come in special class at 10 p.m. 10 p.m. Don't forget to come. Don't forget to come. Now, okay. हाँ हर्ष बोलो क्या डाउट था. हर्ष टेल मी व्हाट इज द डाउट. थैंक यू बेटा, थैंक यू आदित्य, थैंक यू शांतनु. अरे डोंट don't take serious in these type of waste people. Are yaar, हैं? Don't take these people serious. They are not going to do anything in their life. मैं ट्रू टीचर हूं बेटा, मेरे मुंह से निकला हुआ एक एक शब्द सही होता है. तुम जिंदगी भर यही करोगे जो आज कर रहे हो. Don't worry, don't give much focus to these people. Harsh Chaurasia, ask your doubt beta. Okay, acha, one more information I would like to give you that today, like from today onwards, 20% off is going on. That is only for few days. That is only for few days. So if you want to use this, then don't forget this code Shivam101. Okay, and don't forget to come at today's class. Today special class 10 p.m. हर्ष और रसिया, आस्क योर डाउट. बताओ, एक हर्ष यहाँ पे आया, डाउट पूछ रहा है, आंसर दे रहा है, प्रिपरेशन कर रहा है. एक दूसरा हर्ष है जो अपना लाइफ खराब कर रहा है इधर बैठ के. टाइम इज मनी बेटा, डोंट वेस्ट इट. सिंपली वेस्ट मत करो. 296. Okay, so I think Harsh Chaurasia, you ask me in my direct phone number, or directly ask in the group. Directly ask in the group beta, at Shivam Dixit 63. At Shivam Dixit 63. That is my Telegram channel. So you can come and you can ask there. ये लोगों ने दिमाग खराब कर दिया मेरा आज. Sir, I am requesting you to ignore these type of. अरे I am ignoring यार. Life is going to ignore. God is also going to ignore these people. I am telling you. मेरा श्राप है तुमको. भगवान भी तुम्हें भूल जाएगा कि तुम कहीं कभी जिंदा हुए थे. कीड़े के जैसे जिंदगी जियोगे तुम. जो मेरी क्लास खराब करेगा ना, वो कीड़े की जिंदगी जिएगा. श्राप है मेरा. ब्रह्मास्त्र शिवम नाम है मेरा. भगवान का अगर थोड़ा भी अंश है तो तू जा. हर्ष, और मैं स्टॉक में हूं. जा, तेरा कल लॉस हो जाएगा. हर्ष गौतम, कल तेरा लॉस हो जाएगा स्टॉक में. छोड़ो. Okay, so let's meet today 10 p.m. Let's meet today 10 p.m. Okay, bye bye. Already it's late beta. Only 1 hour is remaining. I have to take food also. So let's stop it. Okay.